Okay, here comes the video for the recent 2026 NHT Mathematics Exam 2. Overall, I had a quick look at this paper. It's an interesting exam paper and it minimized the UDF uses, to be honest. Yeah, for certain questions, it required more reading comprehension skills and you had to pay attention to the provided information closely. And yeah, there are a number of conceptual checkpoints you really need to focus on. Okay, so I'll go through the questions. The first one is a quite easy question because you've got a sample size n equals to 300, and this 230 is like the number of success who completed an apprenticeship in the last 10 years. To find a 95% confidence interval, you just go for menu statistics, confidence intervals, and you choose one property z interval. So you have 230, 300, 0.95. And you get a confidence interval roughly 0.719 and 0.815. Okay, so that's option B. Next one is also a lovely pseudocode question. Notice the for loop. The outer for loop for I from 1 to 6, that's 1, 2, 3, 4, 5, 6. And there is an inner for loop from 1 to 6 for J. Print I first, then J, which means you look at the outer loop. You started from, I equals to 1. Then you look at J equals to 1, 2, 3, 4, 5, 6. So you get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. That'll be, the first 6 print. Then you look at I equals to 2. So you have J equals to 1, 2, 3, 4, 5, 6. Therefore, if you look at the nice output, it will be 2, 3. Okay, so option A is the correct answer. Question 3, we have a standard deviation of 2 for a continuous random variable. That's a normal random variable. Mean value is 15, so we have mu equals to 15, and the sigma equals to 2. Remember, this is variance sigma squared, all right? And then the probability that a student takes more than 20 minutes. So if you draw a diagram, this will be, 15 for x, and more than 20, 20 is here, like 2 units. The distance here is like 5 units divided by 2. So the z-score will be 2.5, okay? So I'll draw another axis here. And then the probability for a student to take more than 20 minutes to travel is this guy. So we can write this one as probability x greater than 20. It's also equal to probability of a standard normal greater than 2.5. But we don't have, let's say, probability z greater than 2.5. This is the other side. Therefore, we have to use, for example, one takeaway probability z less than 2.5, okay? Therefore, using the symmetry property, I'll get option D. Okay, for this function here, we have a range of -2 to 1. We want to find a domain. Because this is a strictly, I think it's a strictly decreasing function. If I had a maximal domain, something like that. Basically, you have 2 branches like that, okay, for the rectangular hyperbola. Now, if you solve -2 less than 4 over x plus 2 less than or equal to 1 for x, you actually get -4 to -1, all right? -4 to -1, that is the domain of this function. So choose option A. And if you double check to sketch a graph, 4 over x plus 2, given that -4 less than or equal to x less than -1. You can see this is the largest value, which is included, and this is the bottom value for y, which is -2, okay? Question 5. Newton's method can be applied to find an approximate solution to this equation. So we try to make f of x equals to e to the power minus x minus 2. And then to use Newton's method, we use this iterative formula, n of x equals to x minus f of x divided by the derivative of f of x. So what we can do is define f of x as exponential minus x minus 2. And then we say, all right, the initial estimate is x naught. Therefore, I can say a minus f of a divided by the derivative. So the value of x1 will be 1 plus a minus 2 e to the power a. Option D, okay? x1 is just n of a, which is minus 2 times e to the power a plus 1. If you see a graph reflected about y equals to x, this is finding the inverse. Therefore, we have x equals to 2 to the power y minus 1 add 3. To find a new equation, you can write x equals to 2 to the power y divided by 2 plus 3. Therefore, you have x take 3, then you multiply everything by 2, equals to 2 to the power y. Therefore, y equals to log base 2, 2x minus 3. If you want to use CAS calculator, it's just a solve command, x equals to 2 to the power y minus 1 plus 3, comma y. And now, if you look at this format, it's natural log 2x minus 6 divided by natural log 2, which is log base 2, 2x minus 6, okay? So I believe that's, oh, by the way, I should have a bracket here, which is log 2 of 2x take 6, option A, equation of the image. Okay, so now we consider the following two graphs, f of x and g of x. They had an intersection near x equals to y. However, this time we want to find the solution to f of x plus g of x. So this intersection here is where f of x equals to g of x, which would give us, let's say, g of x minus f of x equal to 0, rather than g of x plus f of x equals to 0. Therefore, we actually need to look at, for example, f of x equals to minus g of x, which means I'm going to look at the, reflected graph. So what I would do is I'll draw a curve like that, actually, bear with me. Oh, how come I couldn't draw a curve? Okay, so that means I need to draw a reflected curve like this, okay? Therefore, I say, okay, this is my y equals to minus g of x. And the intersection between minus g and f is going to lie between 0 and a half. Okay, so I say option A will be the most suitable answer. Lovely, simple conceptual question, but you have to pay attention to details. It's f of x plus g of x rather than f of x minus g of x. Following a sequence of steps is an attempt to solve an exponential equation 3 over 4 to the power x equals to 3. Step 1, we take a logarithm of both sides. Yep, we can take log 2. Use law of logarithms to rewrite the equation. Bring down the x to the front. Yep, that's correct. Step 3, divided through log 2 over 3 over log 2, 3 over 4. That's correct. But then step 4 starts to be a rocky one because you are not actually subtracting the argument. And this is in the format, of a ratio. So you have to use change of base law. The correct step should mean log base 3 over 4 of 3, okay? Something along this line. And subsequently, step 5 is also incorrect. Following that logic is also an incorrect attempt because it would be 2 to the power x equals to 9 over 4, okay? Rather than, writing it as a square root. The question says the first step containing an error. The first step containing an error is step 4. So option C. This is the first error, and this is a second error, okay? Ooh, an interesting one, actually. This is assessing your conceptual understanding, outcome 1, I suppose. A straight line is tangent to the graph of both y equals to x squared plus 4x and y equals to x plus 5 squared minus 4. We want to find the gradient of this line, so it's a good idea to sketch both graphs, x squared plus 4x, and also we have x plus 5 to the power 2 minus 4. So you can see the black graph is a translation of the red graph. They do have the turning point to stay on the same horizontal line, which is minus 4. Okay? To see this, you can actually get the minimum of this graph. So y equals to minus 4, but we would like the gradient of the line. So I'll get dy dx equals to 0. So actually it's option B. It's not the value or the equation of this line. By the way, I think this question can be attempted in a slightly different fashion. If these two graphs were not, let's say, these two simple quadratic to have the turning point level with each other, well, I would do f of x is assigned to x squared plus 4x and g of x assigned to x plus 5 squared minus 4. What I will do is I'll also define the two derivative functions. For example, 2x plus 4 and dgx is assigned to, 2 times x plus 5. And then suppose I don't know the graph, but I know there are two different points on f graph and g graph. Then I can say a straight line to be a common tangent to both graphs. We could form a couple of equations such as f of p minus g of q divided by p minus q equals to df of p. And I can also get the same gradient equals to dg of q. And I can solve these two equations simultaneously to get a p and a q. So therefore, on the first graph, x equals to p equals to minus 2, and the second graph, we have x equals to q equals to minus 5. Then we can try df of minus 2, that's 0, and dg of minus 5, that is 0, okay? So this is a generic approach if you have more complicated functions or more complicated scenario. And in order to find the coordinate, you might do, let's say, minus 2 f of minus 2. This is the point of contact. And you can also do minus 5 g of minus 5. And you get a minus 5 minus 4. All right? Question 10, a binomial random variable. The expected value is going to be n times p. So if n value is fixed, and the p-value is between 0.5 and 1. P increase will result in, let's say, expected value increase. The variance is mp times 1 minus p. So basically, this is like a negative quadratic with an axis of symmetry at, p equals to 0.5. So this bit will be a decreasing bit. Therefore, I'll say ex increase, variance decrease. So option B is the correct answer. Question 11. We have f and g graph. This is like, the root, a quadratic. The second one is a cubic function. Given that the graphs f and g have the same x-intercept, actually, I'd prefer them writing x-intercepts in a bracket, because what if a equals to b? That is another story, okay? So they will only have one x-intercept. But anyway, which one of the following must be true for all possible values of a and b? Well, firstly, if you have, let's say, x equals to a, x equals to b from the second function, the first function to share the same x-intercepts must have x minus a times x minus b as the factorized form, which eventually gives you x squared minus a plus b times x plus a times b. So ab equals to ab here. Therefore, the only possibility is the c term is equal to minus a plus b, okay? Therefore, I would choose option D. All right. Question 12 seems to be a challenging question. Consider the 10 functions, sine x, sine 2x, sine 3x, sine 4x, blah, 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 until sine 10x. How many values of x between 0 to 2 pi exist such that fn x equals to 0 for all integers n with 1 to 10? What I'll do is I'll solve each one using zeros command. For example, sine x comma x given 0 less than or equal to x less than or equal to 2 pi. So we have 0 pi 2 pi. If I try sine 2x, I get 0 half pi pi 3 pi 2 pi. So half pi and 3 pi over 2 won't satisfy sine x equal to 0. It's 0 pi 2 pi. If you try, let's say, 0 sine 3x, you will also just get 0 pi 2 pi. By the same sort of logic, if you try, let's say, sine 4 pi, we just see 0 pi and 2 pi. So only the 3 values here. Let's try the largest value. If you try, let's say, 10x, you can see the calculator can't, let's say, list all specific value. Instead, they gave you a general form. So this m5 is like an integer ranging from 0 to 20. Therefore, when I take 0, that's a 0. When I take, let's say, m5 equals to 10, that's a pi. When I take m5 equals to 20, that's 2 pi. All the others won't share with 0 pi, 2 pi, okay? So it's just, option B. The question is actually asking for how many common solutions do these 10 equations have within 0 to 2 pi. So we only have x equals to 0, pi, 2 pi, satisfying all 3 equations. All 10 equations, actually. Conceptually, this one needs a bit reading comprehension, but once you get the idea, the procedure is just very easy. Question 13, which set of x values is not a subset of the general solution? So for example, if you look at, the solution structure, what I'll do is I'll do solve command, sine 2x equals to square root of 3 divided by 2 comma x. So you can see there are 2 specific general solutions. We say x equals to 6n over 6, that's pi, plus pi over 6. So you have to involve a base angle pi over 6, or actually I'll write this one as m pi plus pi over 6. Or you could have a 3n pi over 3. That's m pi plus pi over 3, okay? So anything equivalent to either one of these, or can be described as, as part of each expression. I would say it's a subset. For example, it doesn't seem to be the same, but if you take k equals to 0, yeah, it's just minus 2 pi over 3. If you take k equals to 1, you'll get a pi minus 2 pi over 3, that's pi over 3. And if you take k equals to 2, you actually can satisfy, let's say, the second one. So this is, yes, a subset. Pi over 3 plus 2k pi. Notice, we don't need, exactly the same thing. If you look at a pattern, that will be pi plus or minus 2 pi, pi over 3 plus or minus 4 pi, etc., etc. And notice this is pi on 3 plus or minus pi. Therefore, this general expressions is contained in the second one. So this is also an OK form, a subset, yes. How about 5 pi plus k pi? Well, this time, if you take k equals to, plus or minus 1, plus or minus 2, plus or minus 3, etc. So you have, these things. Something along this line. And you can see it doesn't quite match, let's say, pi over 6 plus or minus pi, plus or minus 2 pi, etc. So this is not a subset. And to check the last one, for example, 7 pi over 6. If you take k equals to 0, you've got x equals to 7 pi over 6. And if you take, let's say, n equals to 1 from the first expression, it matched, all right? So therefore, this is also a subset you can check for other values, all right? It's a bit creative to see them writing such a question. But anyway, question 14. Consider the system of two linear equations below A and B are real numbers. The system of two equations has no real solutions, so they are parallel to each other. Therefore, you can say the ratio between x, the ratio between y, they are equal to each other, but it's not equal to 1 to 2. So we can have A over 2 is equal to B over negative 3, but it's not equal to half. I can get, for example, 2b equals to minus 3a, something along this line. And then 1 and 2 satisfies equation 2. Therefore, we can say, all right, how about I substitute, 1 and 2 into the second equation, say a plus 2b equals to 2. Therefore, we should have a minus 3a going to here. That's 2. So a is actually, minus 1, all right? And then 2b equals to minus 3 times minus 1, so that's a 3. b is going to be 3 over 2, okay? Therefore, the equation 2 can be written as minus x plus 3 on 2y equals to 2. And you can see the numbers, they don't quite match each other because you will get, if you multiply by negative 2 both sides, this will be 2x minus 3y equals to minus 4. And it doesn't match 1. Therefore, these two are parallel lines. And you can say, all right, check the x values. Solve 2x minus 3y equals to minus 4, comma y, given x equals to 4. Y equals to 4. So the solution, one of the solution can be given by x equals to 4 and y equals to 4. Question 15. We have a continuous function which has an average value of 2 over the interval, minus 1 to 1. So that means half minus 1 to 1 f of x dx equals to 2. So it gives you minus 1 to 1 f of x dx equals to, for example, a 4. Okay? The next thing is a couple of statements. We have g of x, which is a linear transformation of f. We would like to see the average value. The average value, let's say, if we try, by the way, this means a dilation factor of 1 over n horizontally. So if you see the interval like a minus n to n or minus n to n, we actually don't multiply n to the interval. We divide everything in the interval by n. So we need to look out for, let's say, minus 1 over n to 1 over n. And let's say the average value over minus 1 over n to 1 over n for this function is 2 over n underneath 1 over 2 over n, from minus 1 over n to 1 over n, m times f of nx plus c dx. So you will get a 2 over n integral minus 1 over n to 1 over n, m times f of nx dx plus 2 over n integral from minus 1 over n to 1 over n c dx. Okay? So actually, I'm a bit running out of space here, so I'll just rub this out. And for the second integral, you can compute that by your CAS calculator, or if you wish, you can do that by hand, but just save a bit trouble. 2 over n minus 1 over n to 1 over n c dx. So that is, like 4c over n squared, okay? 4c over n squared. Yeah. And also, should I have, let's say, oh, sorry, typed the wrong thing. Bear with me. This should be n over 2. didn't realize I forgot to take the reciprocal, n/2. So let's try that again. Delete this one, n/2. Yep, that's just C. So the second part is a C, add a C. We must have an add a C. But how do we prove this first bit is 2m? Well, for the first bit over there, we can make a substitution. Well, I have to use a bit skills from specialist math. U equals to ns, du dx equals to n. Therefore, dx is 1/n du. And if you're tracking, let's say, minus 1/n to 1/n, x equals to minus 1/n. The u value is minus 1. X is 1/n, my u value is 1. Therefore, you would get a half m times m integral minus 1 to 1 fu of 1/n times du. So the n's can be canceled out, okay? And m is a multiplier. Remember, this bit will now have a number 4. So 4 divided by 2 times m. So that is 2m plus c. Indeed, a bit algebraic heavy. The option D is the correct answer. If only they could leave a bit more space below question 15. This is a bit squashy. Anyway, question 16, we have a function like that. Dilation factor half from the y-axis, dilation factor 2 from the x-axis, translation 2 units in the positive direction of x. So what you could do is define this function first. F of x is assigned to cos pi times x over 6 times sine of pi times x divided by 3. And the h of x is dilation factor 2 from x, dilation factor half, that's 2x, and then translation, 2 units to the right. So this is what I'll define. And we want to see a period. So if it's a period, I would say x plus 3 equals to h of x. I just want to check if this is true. If this is true, 3 is a period. But it doesn't show me a true output. Therefore, I'll try another one. Say x plus 6. That's true. And if I try x plus 12, that's also true. X plus 24, that's also true. Well, in this case, I would take the smallest positive value because 12 is a multiple of 6. 24 is also a multiple of 6. So the minimum positive period would be, let's say, 6. Okay? But depending on how you're gonna, interpret the definition, period. Anyway, I think the intended answer is B. Oh, fantastic question. We have a graph f of x. Looks like a slightly concave up and decreasing. And g of x looks like a circular function in the format either sine or cosine. It's also between, 0 and 1.0. We would like to see the composite functions graph. So for example, if you want to check the composite function graph, remember you have x mapping g, g map to f. So if you put this one as a g, this one as an f, f versus g, we can actually see some correspondence. For example, when x equals to 0, my g equals to 0. So when my g is 0, look at this axis, my f is going to be 1. And if I try x equals to, for example, 1/4, my g is 1. Therefore, my f is going to be here, equals to 0. So when x equals to 1/4, f value should come back to 0. So option A, option B doesn't satisfy this property. And now, by some symmetry, if you try x equals to 0.5 or half, my g comes back to 0 again. So f will come back to, 1 again. Therefore, I would say only option D will satisfy this format, okay? And it's quite symmetrical. When I attempt this question earlier, I actually adapted a slightly different approach. But that is based on your knowledge to the specific functions. So a function like this, it can be my f of x. You could say this is, for example, 1 take away x to the power 2/3. And just zoom in, okay? Just zoom in. So for example, yeah, it has a similar curvature. And also if you try, for example, a half minus a half cosine of 4 pi times x, just restrict that between 0 and 1. So you can see this is a similar graph to the g of x provided on the exam paper. And you can just do, for example, f1 of f2 of x. So it gives you a shape of w, right? And if you know other functions in this format, for example, you might want to try, let's say, another power, say 3/2. This is actually a graph of a half asteroid, okay? So you could actually get a more accurate graph, okay? A more accurate graph, and it's very close to option D. So that is another possible approach. As to how I came up with this equation, well, notice the amplitude is half. Also, it's in the shape of negative cosine, reflected cosine, and the center line is half. So you can say it's half, take away half cosine. The period, because this red graph has 2 complete cycles, then you can figure out the m value is 4 pi. All right. So that's that. Question 17. Question 18, we would like to get the antiderivative graph. So you can see the graph exhibits some sort of, exponential behavior, increasing exponential behavior. And you should also get a turning point at a 3. Therefore, what you could do is guess a graph like x minus 3 squared times exponential x. So you can see it exhibits this sort of behavior, but it's too high. I can put a dilation factor, for example, 1/15 or 1/20. Does that look better? Okay. To make sure the turning point, the maximum turning point is lower than 1. Or if you wish, you can use, let's say, 10 or whatever. Okay. Doesn't really matter as long as you get the correct shape. The next thing is you sketch an antiderivative. So you can see the graph should have a stationary point of inflection at x equals to 3. And comparing the options, notice that after your integration, you add an integration constant c. So this shape, this curve can be either higher or lower, okay? For example, if you want it higher, you can get it like that. Or if you want it lower, you can subtract the number, okay? Or you can say we subtract by 2 or subtract by 1. So that will be, a closer, match to option C, okay? Anyway, we can move on and have a look at the last few questions. Question 19, a basketball player has 3 attempts to score from a free throw line. If the player scores at least twice, they win the game. Assume that for each attempt, the probability that a player will score is P. P is between 0 and 1. The outcome of each attempt is independent of all others. So this is likely a binomial distribution. We can call it binomial 3, P. And given that a player wins the game means, okay, probability of W must be at least 2, okay? Find the probability that exactly one of the first 2 attempts was missed. So that means if I want, let's say, W greater than or equal to 2, we can have successful, W equals to 3. Or successful, not successful, not successful, or not successful, successful. So these 3 things will be the probability of W equal to 2. This will be W equals to 3. Based on the conditional statement, we only consider the 4 cases, and the specific requirement is exactly one of the first 2 was missed. So I would like to see which cases had, an N in the first 2 outcomes. So it's only these 2. Therefore, each one will have, let's say, p squared 1 minus p, and 2 lots of them, okay? Eventually, w greater than or equal to 2, the conditional probability will be the numerator, 2p squared 1 minus p, and then w greater than or equal to 2, we will have NCR 3 choose 2 times p squared times 1 minus p plus p to the power 3. So you will get something like that, p squared times 3 minus 2p. So you can actually cancel out, the p squared. And that's why you get a 2 times 1 minus p divided by 3 minus 2p, okay? It's a conditional probability. So basically, this is like, a slightly more challenging probability question. It required you to, have a comprehensive skill set. But most importantly, you need to build a link between the binomial distribution and all possible specific outcomes it will generate. All right, question 20. Question 20, a soup company is building, let's say, a cylinder of volume V. So this is the height. This is the radius. So V equals to pi r squared times h. Therefore, your h is V divided by pi r squared. The surface area includes the base and the top. So we would like S equals to, 2 pi r squared, top and bottom, plus, notice this is 2 pi r, this is h, so we have 2 pi r times V divided by pi r squared. And that gives me 2 pi r squared plus, 2V divided by r. Then, in order to minimize this guy, I probably would say F minimum 2 pi times r squared plus V divided by r, comma r. So you would get, let's say, this value, which is like, 2v to the power 1/3 divided by 2 times pi to the power 1/3. But that's the r value. Then I have to, let's say, sub this r value into the surface area function. So you get something like 3 times, pi to the power 1/3 times 2v to the power 2/3 over 2. If you try, let's say, 3 times, this expression means the cube root of 2 pi times v squared. I think I've got, let's say, a slightly different answer, but let me do that again. Forgot to type a 2. Yep, this time it looks better. And then I'll just do a substitution. See, you have to enter the expression carefully enough. Yeah, this one looks more likely, the answer. Yep. So that is, this one. So option D, okay? Overall, I would say the 20 multi-choice questions, they are lovely to work through, okay? Then let's have a look at the extended response questions. Glass of water is placed in a refrigerator. Okay, temperature is given by this function, initial temperature, equation of the asymptote. And after 2 hours, the temperature is like, 9 degrees Celsius. So what I'll do is, I'll first define the function. F of t is assigned to 6 plus 27 times exponential minus k times t. Okay, and f of 0, that's 33 degrees Celsius, Equation of the asymptote. Notice that the graph has the following shape. Okay, so for example, the graph could go this way. This is y equals to 6, okay? So you say y equals to 6. It's a, cooling process, Newton's law of cooling. Find the value of k. We need to use f of 2 equals to 9. Get an equation and get the k value. So we can solve that for k. And show that f of t can be written in this form. Therefore, f of t is 6 plus 27e to the power minus log e of 3 times t. So 6 plus 27e to the power log e of 3 as one item raised to the power minus t. Therefore, you get a 6 plus 3 to the power 3 times 3 to the power minus t, and that's 6 plus 3 to the power 3 minus t. So you probably need to show some valid logarithmic operations or manipulations like regrouping e log e3, or you can say minus t is one chunk. There are other equivalent operations, but this is a hence show that. So you probably need to get a correct value of k and then show the substitution and a successful manipulation into the required form. And now you can also define f of t again as 6 plus 3 to the power 3 minus t. And how long after being placed in the refrigerator does it take the water temperature to reach 8.5? So we can solve f of t equals to 8.5 comma t, 2 decimal places. That means, okay, t is 2.16595, which is rounded to 2.17 hours, I suppose. 3 hours after the water is placed in the refrigerator, T is 3, the refrigerator door is open, the temperature of the water that then increases at a rate of 14e to the power minus t as g dash t. H includes f and g, the two functions. It's continuous. Therefore, at t equals to 3, the y values will be equal. So what I'll do is, first I'll get f of 3 for a continuous joint. H, let's say, H3 equals to f of 3 is defined. That's 7 degrees Celsius, which is also equal to g of, g of 3. Okay, because it's a continuous connection. To find g of t, what I'll do is I'll do g of t equals to the integration starting from 3 up to t, and then 14e to the power minus x dx. We add, let's say, g of 3. So actually, I can just do 3 to the power t, 14 exponential minus x dx plus g of 3, that's 7. So you get a function like that. You probably can expand this function. So you actually get minus 14 e to the power minus t plus 14 e to the power minus 3 plus 7, okay? Of course, if you just approach this problem with a standard traditional procedure, you just integrate add c solving to find c, okay? You could also do g of t is assigned to, let's say, this bit, okay? Now, find h dash of t for t not equal to 3, and verify that the function is not differentiable at t equals to 3. It means, for example, if you define your h of t as f of t between 0 less than or equal to t less than or equal to 3, and g of t is t greater than 3. And then you can just take the derivative h of t So you can see the equal sign is removed. Therefore, the graph is not differentiable at t equals to 3. Something very similar were assessed in the previous years. So yeah, you have to get, let's say, the correct rule and the correct domain and verify that it has to show, let's say, if you try g dash of, let's say, a 3, you can write it approaches to some value like shift minus t, g of t, given that t equals to 3. It gives you a 14e minus 3. And f dash of 3 is approaching to negative log e3. So these two values are inconsistent. Therefore, h of t is not differentiable at t equals to 3. So the problem is solved. Notice that the booklet says question 1 continues on next page. So you have to, let's say, keep going. The temperature can also be measured in degrees Fahrenheit, okay, rather than degrees Celsius. So there is a conversion formula, P equals to 1.8 or 9/5 H of T plus 32. A sequence of two transformations, dilation followed by a translation. So you have to say a dilation factor of 9/5 from, usually I say from the x-axis, but in this case I'll say from the t-axis or horizontal axis. Then you say a translation by 32 units or 32 whatever degrees upward, okay? In this case, I just say 32 units upward, okay? Alternatively, if you want to use, let's say, a translation first, then a dilation, you have to factorize this function. For example, P of t is going to be 9/5 h of t plus, 160/5, okay? And you have to take, let's say, a 9/5 out. For example, you can say 9/5 out, h of t, and you need to add a number. So this number, if it's divided by, 9/5, let's say 160/5, divided by 1.8, you actually get a 160/9, right? 160/9. So this is the harder part to observe. Therefore, from ht to ht plus 160/9, then you multiply a 9/5 on top of both terms. This is what it means by a translation followed by a dilation. So we say translation by 160/9 units. 160/9 units up, then followed by a dilation factor of 9/5 from the t-axis or from the horizontal axis. Okay, something like that. Okay, so that is question 1. Seems fair. Let's move on and have a look at question 2. Okay, a lovely function to work with. X over x squared plus 1, coordinates of both stationary points, area bounded by the graph, -1 and 1, and the x-axis. So if you plot the graph, we say x over x squared plus 1. And then zoom that in a little bit. Looks like the turning points will be, yeah, 1, 0.5, and this is -1, -0.5, I suppose. And then the area, this region is below the axis, this region is above x-axis, so they are identical. You have to double the region. And the equation of the tangent at the origin. So basically we say -1 minus 0.5 and 1 comma 0.5. They are two stationary points. And the area, this is -1, this is 1, is two lots of 0 to 1, f of x dx. And I can easily compute, let's say, the area, integral f1 of x from 0 to 1 times 2. So you get a log e of 2, okay? And equation of the tangent line, so y equals to tangent line through the origin, f1 of x comma x equals to 0, y equals to x. Very simple. Equations of the tangent lines to the graph to have a gradient -1/8. So we first solve shift minus the derivative of f equals to -1/8 for x. So we will have f dash of x equals to -1/8, giving x equals to plus or minus √3. Then we can say at x equals to minus square root of 3 or at x equals to √3. We say yt1 equals to minus x/8 minus 3√3 divided by 8. At x equals to square root of 3, yt2 equals to minus x/8 plus 3√3 divided by 8. Okay? All right, let a, b be are real numbers. A is less than b and they are both positive. Show that using algebra, okay? Using algebra, that the average rate over AB is given by this thing. So first of all, we say FB minus F of A divided by B minus A equals to 1 over B minus A. That's one chunk. Then you have B divided by B squared plus 1 minus A divided by A squared plus 1. So you probably need to show the clear algebra working, okay? And then it's 1 over B minus A. And then we combine the two parts. So we will have an a squared plus 1 times b squared plus 1. We're now combining the fraction, and a b times a squared plus 1 subtracting a times b squared plus 1. We can now show some expansion. 1 over b minus a, we have a squared b plus b minus ab squared minus a divided by a squared plus 1 times b squared plus 1. Okay? The next thing is my target is to cancel out, let's say, the b minus a because the final expression doesn't have 1. So 1 over b minus a, let's to write it here, multiplied by, you've got, let's say, I'll write a b minus a first. Then it's actually plus a squared b minus ab squared. Okay, that's another part. Over that. So we will need to get, let's say, a common factor, say 1 over b minus a. We've got a b minus a here. Then if we take minus ab out, this will be b minus a. So you can see it's, here a lot of working, but it's a 3 marks question. Therefore, just like the last year. Last year, the November paper had also had a 3 marks question. Anyway, for show that. So you can cancel these two terms now, and that's just 1 minus ab. divided by a squared plus 1 and a b squared plus 1. Altogether, you completed that show that question, and yep, this is like the final step. So it's quite a bit of work. Hence or otherwise find A in terms of B such that FA equals to F of B. So if FB equals to F of A, the average rate is going to be 0 because they're subtracting to get a 0. Therefore, you can have 1 minus AB equals to 0. AB equals to 1, so A is 1 over B. Okay, they are reciprocal of another. Okay, so that's that. And then what else? Okay, now we look at, let's say, some sort of family of functions. Let's define this one. G of x equals to x divided by x squared plus k. And the stationary points, x values only. Therefore, we take the derivative equal to 0 for x. So you get minus root k or root k. That is solving, g dash of x equals to 0, giving x equals to plus or minus the square root of k. Find the all values of k such that g is strictly decreasing for x, greater than or equal to 1. You might want to observe from the, slider. Here I'll put a k1. Also, if you wish, you could put x greater than or equal to 1. I don't need the y values to be too large, so I just change the viewing window. For example, if your k is 1, so the graph is decreasing from 1 to infinity. If k is larger, you can see there is a turning point. K is larger, there is a turning point, so that doesn't quite work. So if you try, let's say, some smaller values of k, you can see when k is less than 1, there is no turning point within this subset of the domain. Okay, so I think the k value has to be first it's greater than 0. Second, it's less than or equal to 1. Or you could say square root of k is less than or equal to 1. Okay. And then you will get, let's say, 0 less than k less than or equal to 1, something along this line. All right. Okay, a lovely question, but not intrinsically hard, I would say. Okay, let L be the straight line passing through the stationary points of G. So if you look at the shape of the graph, it's a wavelet shape. Okay. And I would like to get, let's say, a straight line. So it must come through that, let's say, get through the origin. And this is root k. Therefore, first I will define the line YL of x, which is like the rise over run. So we will have g root k divided by root k times x. Okay. That is g of square root of k divided by square root of k, rise over run times x, the origin. Okay, so you get x divided by 2k. And then the area, it will have two parts. One part is here, another part is here, okay? Area equals to 2 lots of 0 to root k. So we've got g of x subtracting x over 2k dx. Let's see what we get. 2 lots of integration 0 to square root of k, g of x subtracting this answer here for x. So you get a 2 log e2 minus 1 all over 2, okay, square units. Make sure you have, let's say, a 2 in front of the integral because of the symmetry. Okay, total area of the regions. Anyway, yeah, that is question 2. And then, question 3. 2 hiking apps, App A and App B, provide information about hiking trails. So we've got this function. Let's do it this way. Firstly, we want to sketch the graph, so I make this 50. Don't care about this bit, can just ignore that. Put a 0.1, okay, 0.1, and also I'll put just 0. So then I'll put a 10 over there, a 10 over there, and yeah, I just do, let's say, x over 250, and I'll just do, let's say, x minus 45 square over 15000. So you can see they intersect at, intersection 15 0.06, okay? So this is one joint you have to be aware of, I suppose. Over there, okay? And when x equals to 5, this is 0.02, I suppose. Let's try f1 of 5. Yep, 0.02. So at 5, I'll get a straight line segment here. The question says you have to, let's say, draw over a domain restriction like a 0 to 50, okay? So the otherwise bit from here to here, I'll put a hollow circle here. The graph seems to have a turning point at a 45. So it's here. Now I'd like to see a nice curve. Okay, I'll just do that. You get a nice quadratic function, something like this, okay? And don't forget about, let's say, the continuing part, which is a flat line from 45, 0 to 50, 0, okay? The question didn't ask for any labeling on the coordinates, but yeah, I just say this is 15, 0.06. This is 0, 0. This disjoint is 5, 0.02. And this is 45, 0. This is 50, 0, just for reference only, okay? Anyway, find the mean distance. Find the mean distance, I would say, well, you have to integrate from, the 5 to 15. So shift plus 5 to 15 x times f1 of x dx plus shift plus 15 integral from 15 to 45 x times f2 of x dx. 107 over 6. So you can write expected value of x equals to integral from 5 to 45. And it's f of x times f of x dx, giving you 107 over 6, which is rounded to 17.8 kilometers, okay? 1 decimal place. All right, app B. App B, let's call it, a normal distribution. Mean is that standard deviation is 5. So let's call it y is a normal distribution 16.5, 5 squared. And the probability for the selected hiking trail to be longer than 12. So we say probability of y longer than 12. Norm CDF 12 infinity 16.5, 5. 0.8159399 rounded to 0.816, 3 decimal places. The minimum distance to be classified as difficult. Difficult means the longest 15%. So this bit will be 0.15. The other bit will be 0.85. So this is, the distance y. We would like probability y less than or equal to y equals to 0.85, or y greater than y is 0.15. We can use inverse norm 0.85. Must be a left tail. And we have 16.5, 5. Y value is 21.682. Rounded to 21.7 kilometers, okay? Use the normal rounding. A hiker randomly selects 10 hiking trails from app B. Assume that the 10 trails are selected independently. Find the probability that exactly 2 hiking trails are classified as difficult. So let's call it, a W is a binomial distribution. N equals to 10 trails. P is the probability of success for one trail to be difficult. Then I'll get the probability of W equals to exactly 2. So that's 10 choose 2 times 0.152 and 0.85 to the power 8. But what I'll do is I'll use binom CDF, or PDF is fine. 10, 0.15, 2, 2. Okay, so that gives you 0.2758966. So that is 0.276, 3 decimal places, okay? All right. Random selection of 10 hiking trails from app B. P hat is the random variable representing the sample proportion. Want the probability P hat greater than 1/3. We have defined a W before, so we can write P hat equals to W divided by 10. So P hat larger than 1/3 is equivalent to W greater than, 10 divided by 3. So it means W is, starting from 4, 5, blah, 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 until 10, okay? Therefore, probability of P hat larger than 1/3 equals to probability of W greater than or equal to 4, up to 10. So we can use binom CDF from 4 to 10. Or you can even use, let's say, a fraction in TIS by 10/3, giving you the same value. So that's 0.04999697. Round it to 3 decimal places, you get a 0.0, I would say 50, okay? If you use the rounding command, round this value to 3 decimal places, you need to fill up an extra 0, more than just 0.05, okay? Has to be a 0 here. Okay, consider a random sample of n hiking trails from app B. Use a normal approximation to find a minimum value of n such that the probability that 10% or more of the trails are classified as difficult is at least 0.95. So P hat, in this case, I'm using mu equals to the probability of success, which is 0.15. And the sigma equals to square root of P times 1 minus P divided by N, which is equal to 0.15 times 0.85 divided by N, okay? So my target is to have this P hat thing greater than or equal to 10%, 0.10. We want to have at least 0.95. In this case, you can either use trial and error, or you can use inverse norm CDF. Because now I'm going to say, all right, if it's equal to 0.95, for example, consider probability Z, larger than or equal to ZC. larger than or equal to 0.95. Then probability Z less than or equal to ZC is less than or equal to 0.05. So what happens is, if you use inverse norm 0.05, you get a Z-score, all right? You get a Z-score. So put ZC equals to minus 1.64485 equals to the specific p hat value, take away the mean value 0.15 divided by the square root thing, which is the standard deviation, or sometimes we call it standard error. And then we will get an m value. Because this time we are using a normal approximation, 0.1 minus 0.15 divided by square root of, 0.15 times 0.85 divided by n, comma n. So you actually get n equals to 137.9827. So rounded to the nearest integer, we will get a 138, okay? Or actually, you can use, let's say, this command. Actually, it should be larger than or equal to. This thing should be larger than or equal to. Yeah. So basically, you would like to see, n larger than or equal to, 137.98, something along this line, okay? In all these places, you can just use equal sign instead, because you're doing the rounding at the final step to get it to the nearest integer, right? Anyway, okay. A hiker randomly select either app A or app B, so you can draw a diagram with equal probability. So app A, app B, 50-50. We could have, let's say, app A, we have the letter X longer than 15. App B, we have the letter Y for the normal distribution longer than 15, okay? So we would like to have the probability of, distance longer than 15 kilometers. This is equal to probability of A intersecting X longer than 15 plus probability B intersecting X longer than 15. So basically, we can compute from the previous part. In part A, we had a probability density function like that. If it's longer than 15, it's just the area under the parabola. So we can actually get, just this integral. We have 3/5. So we have 0.5 times 0.6, something along this line, okay? Coming from, the integral. And then we add 0.5 times a norm CDF, 15 to infinity. The mean value was 16.5, 16.5, So you get, let's say, a decimal value, 0.6179113. Eventually, you just do that times that plus that times that. So the final answer is 0.60895. Rounded to 0.609, okay? 3 decimal places. And given that the selected trail is longer than 15, so we would like distance longer than 15 kilometers. Find the probability that is selected from app A. Selected from A. So you actually get a probability of A intersecting distance longer than 15, which means it's X longer than 15, divided by probability, the total probability distance longer than 15. Therefore, you get a 0.5 times 0.6 divided by 0.60895, etc., etc. So you can just use that divided by that I think it will be, roughly 0.4926466, which is rounded to 0.493, okay? Try not to truncate too early, but in this case, because doesn't differ by too much. Actually, if you use 0.609, you will still get, let's say, this value rounded to 0.493, but try to keep as many digits as possible, all right? So another extreme case, if you round it incorrectly, what will happen is 0.61, you actually get a 0.492 rather than 493. So be very careful. Keep more digits or more decimal places, okay? All right, finally, this question. Well, this question was a creative one in my opinion because you couldn't actually figure out the specific rule according to this diagram unless you spend a hell lot of time, be creative using some power 5, power 6 sort of function. And yeah, this is a differentiable function with domain 0 to 5. We have the following turning points: 1, 2, 2, 0, 3, 3, 4, 1. So the values for which the derivative is equal to 0, we have x equals to 1, 2, 3, 4. That's it. And then find the real values for the graph equal to k, intersecting with a horizontal line to have exactly 2 solutions, or that to have 3 solutions. So in order to have 3 solutions, you get a horizontal line here to strike through the curve twice. Or you can have a horizontal line here to strike through the curve twice. Therefore, your k is actually equal to 0 or k equals to 3, okay? For 2 solutions. 2 solutions, 2 intersections, 2 solutions. If you want exactly, let's say, 3 solutions, okay, so the horizontal line should strike through, let's say, the curve 3 times. As long as this line is lower than 3, but you can't really get, let's say, this thing larger, equal to 2. Otherwise, you strike through the curve 4 times, okay? So I will get, let's say, k larger than 2 but less than 3. Or is there any other places? Yeah. So for example, if it's larger than 0, but try not to touch here, otherwise you will be hitting the curve 4 times, okay? So you have to say k is larger than 0 but less than, for example, 1, okay? 0 to 1, 2 to 3. Okay. When the graph of y equals to f of x is reflected in the x-axis, its image has 2 local maximum. So if it's reflected in the x-axis, we want the 2 local maximum. Well, you could get a graph like that, okay? And like that, like that, and like that, okay? So something like this, okay? Something like this. So the local maximum will be here and here. So that's 2, 0, and 4, minus 1, okay? Let me double check. Yep, 2, 0, 4, minus 1. And then the function f has the property that when the graph is reflected in the x-axis and then reflected in the y-axis, the image can be expressed in the form f of x plus b plus c. So we want both reflections. We want to find b and c. This graph. Okay, so what happens is if you had, let's say, here, 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 minus 3, 3 here, minus 4, minus 1, and here. So you probably get, let's say, just draw this graph nicer. Actually, so the graph may look like that. All right, looks like, yep. If we translate this black graph to this, coffee color or latte color graph, we could say, okay, from 5 to 0, that's 5 units to the left, or 0 to minus 5. Yep, 5 units to the left. Then we need to shift this corner down by 3 units to match 1 here, and shift that down by 3 units. Yep, so we say shift f of x 5 units left and 3 units down. So in order to answer the question, this b value has to be 5, because from f of x to f of x plus 5, this is a shift of 5 units to the left. And then c value, shift that down, that's negative 3. All right, yeah. It's a lovely, symmetrical property. But anyway, the graph of y equals to f of x is shown again below. So if the domain is 1 to 2, state the domain of h1. H1 is the inverse. So my range of f is now 0 to 2. So that is the domain of the inverse, h1, okay? And h1 of 2, for example, h1 of 2 equals to f inverse of 2. So on the graph, f what equals to 2? f1 equals to 2. Therefore, h1 of 2 equals to f inverse of 2, giving me 1, right? So that is, the final answer. Okay, next. Let h of m be the inverse function of f when f is restricted to have a domain m to m plus 1. So the interval length, as I made a small annotation here, is equal to 1. For a particular value of m from 0 to 4. In order for the inverse function to exist, ym must be an integer. Well, we want hmx. Actually, I'll say want f of x to be 1 to 1, okay? So h of mx equals to f inverse of x exists. But you have to, let's say, explain that. In here, if I take m equals to, 0, 1, 2, 3, 4, you would have, let's say, 0 to 1, because the interval length is 1. 1 to 2 is one example. Then another example is possibly 2 to 3. And you could have, let's say, 3 to 4. And then 4 to 5, okay? We can say as the interval length is 1, have to choose 0, 1, 1, 2, 2, 3, 3, 4, or 4, 5. Other than those options, those restrictions, we can't really get, let's say, a 1-to-1 function. okay? Or you could give a counter example, but that's less rigorous. For example, you say, okay, if m equals to 0.5, then you get a from 0.5 to 1.5. This is a many to one case. So if the interval length is fixed to be 1, then we can only choose 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. So these choices will be, one-to-one inverse function. And find the values of m such that hm1 is an integer. Well, because this part 2 has the same indentation as part 1, they both lie under the umbrella of part E condition. Therefore, in order for hm1 to be an integer, we would like to look at, let's say, y equals to 1. Look at y equals to 1. Because that was the previous output before you take the inverse. So the only integer point is 4, 1, okay? The only possible hm1 equals to 4 only. This is the only integer. But the question wanted m values. So what does it mean by m value? The left endpoint of, the domain restriction. So if you make, let's say, this point can either, lie on this green part or on this black part. Therefore, we could either take m starts from 3 up to 4 or m equals to 4 up to 5. Oh, what a question. So many things to consider. So m equals to 3 or m equals to 4. Okay? That's why the question says the values of values of m. All right, F. Finally, we have a specific rule to work with. You can see for the whole question here, can you use, your CAS calculator really well? Nah, for most of the questions, you don't actually use your CAS calculator. You have to use, let's say, your mathematical judgment, all right? And g is from minus 0.8 to 1.8, and x cubed minus x squared minus x plus 3. So what I'll do is I'll create another, a function. I'll call it g of x is x to the power 3 minus x squared minus x plus 3. To find the range, well, you can draw a graph, definitely, g of x. You can say minus 0.8 less than x less than, 1.8, something like that. Yeah, you can see a graph like that. And just notice the right-hand side, this is the highest point, but it's a hollow point. The lowest point is over there. So we can say analyze graph minimum 1, 2, terrific, a whole number value. And then in order to find that, I would take, if you take g of 1.8, yeah, 3.792, okay? Lowest, g of 1 equals to 2. Highest, g of 1.8 approaches to 3.792. Therefore, the range of g is square bracket 2, 3.792, round bracket. Notice this is an exact decimal, but we take it like that, a round bracket. We can also write 474 over 125. Why does why does the question say show that fg is defined for all x belongs to minus 0.8 to 1.8? We say for x belongs to minus 0.8 to 1.8, g of x belongs to 2, 3.792. This is a range. And is that a subset of the domain of f? Domain of f was overall 0 to 5, okay? Yes, 0 to 5 captures this thing. Therefore, the range of G is a subset of domain of f, and fg of x is defined. So you have to, let's say, sort of refer to the specific number set and argue that this number set is contained within 0 to 5 and explain the theory, okay? Quote the specific number set and refer to the theory. And the minimum value of fg of x and the value of x. So now, just treat this one as fg. You can see there are quite a few questions or question parts on this exam paper which refer to the composite function theory. So instead of looking at fgx, we could quickly look at, let's say, this diagram, okay? Or just, actually I don't have to rub this out, but yeah. I'll get a quick sketch. So that's that. Okay. So we know this point was 0, -1. This was 2, 0. This is 1, 2, I suppose. This is 4, 1. This is 3, 3. And this is, 5, 4. Let y equals to fg. So if we think about, let's say, the variations, like just, this is g, this is f. Then my g value can only take 2 to 3.7 something, not yet to 4. So it's from here to roughly here, okay? So this is like, 3.792, very close to 4. So only the yellow part. Therefore, the minimum value of fg is going to be 0, okay? Mean value equals to 0. When, notice this axis is g, g of x equals to 2. So what does that happen? Make sure you realize x belongs to -0.8 to 1.8. So where do I get a gx equals to 2? It's here, only this point. X equals to 1 only, okay? And try not to write that as a pair of coordinates because the question didn't say find the coordinates of the minimum point on y equals to fgx graph. It actually asks for the minimum value of that and the value of x, right? Finally, find the x values for the stationary points of fg of x. Well, oh no, dear. This is a composite function. So let y equals to fg of x. To find the stationary points, we have to put dy dx equal to 0. I'm going to use the chain rule, g dash x times f dash of g of x equal to 0, okay? And also, because the g values can only take, let's say, G can only take the values between 2 and 3.792. So case 1, we actually get the first thing, g dash x equals to 0. And x has to be larger than -0.8, less than 1.8. So we can solve that equation from the CAS calculator. So we will have these two values. Seems good. Case 2. Know that from part A, f dash of x equals to 0 and x equals to 1, 2, 3, 4, right? So those 4 values. But only 2 and 3 will satisfy 2 to 3.7 something. So we knock this out. Therefore, we will have, a case 2. Case 2. G of x, the inner part, has to be 2. and that gives me x equals to what? I think that's x equals to 1 from the previous part. And case 3, g of x equals to 3. So what will happen is, if we solve g of x equals to 3 for x, do they satisfy the domain restriction? Yep, it's larger than minus 0.8. This is less than 1.8. Good. So we get x equals to 0, x equals to 1 plus or minus square root 5 divided by 2. Oh, nice, golden ratio. This number is golden ratio. Overall, we have these values. X equals to minus 1/3, 0, 1, 1, 1 plus or minus root 5 over 2, okay? The reason why I write the 1 twice is because this x equals to 1 repeated. Actually, this case is implied here because it's giving a turning point on the gx graph anyway. But anyway, we analyze all 3 cases. So, yeah, this is everything I would like to go through. Seems like a lovely exam to work through, but you have to pay attention to some traps and really understand what's happening within each question. What are they asking for? Have I answered, let's say, everything they need? Let me tell you, if I was taking this paper as a student under the exam condition, I may not get, let's say, full marks. But anyway, hopefully you understand the key things I explained in this video. Yep. Good luck to your November exam preparation. I'll see you guys soon. Bye.